Okay, we're looking at doing these sample problems for Ashley Johnson, and she's enrolled in Chem 1115. We're going to work on the first 10 problems of this problem set for Unit 4. You will need a periodic table, a list of common polyatomic ions, and a calculator, which I can now show you in a picture. So, we're first charged with seeing how many moles of zinc are in 116 grams of zinc. In order to do this, we need to use our periodic table. So on the periodic table, we can go over here and we find zinc, right? And zinc is atomic number 30, but what we're really interested in is the atomic mass, or the molar mass is what we're going to refer to it as for zinc, and it is 65.39. And what that means is if we have 65.39 grams of zinc, that means we have 1 mole of zinc. And if we have 1 mole of zinc, that means we have 6.02 times 10 to the 23rd atoms of zinc. So all of those things are equal. 69.39 grams of zinc equals 1 mole of zinc. 1 mole of zinc equals 6.02 times 10 to the 23rd atoms of zinc. If I have this number of atoms of zinc, I will have that mass of zinc. I will also, by definition, have 1 mole. So we have to use what is on the periodic table as a conversion factor in order to solve this problem. So in solving the problem, you're probably using brackets to do so. So hopefully that is the case. That's how I'm going to show you. And I'm going to set up a bracket this way. So what you should always use is the number that is provided in the problem. In this case, we're given 116 grams. So we'll write that as our first part of our problem, 116 grams, and we'll put in zinc. And we'll always use the unit and then whatever it is, element or compound that we have there. Unfortunately, I'm using some kind of shape recognition pen, so some of my handwriting changes, so apologize for that. But we have 116 grams of zinc. Now we have to just write the conversion factor of that. And the conversion factor is simply a ratio of equivalent values. So we already have that. We know that 65.39 grams of zinc equals 1 mole of zinc. So here is our ratio. Now, because we put grams in the top of the bracket, we're going to put grams in the bottom of the bracket. So we have grams of zinc, and we're wanting to convert to moles of zinc. If we were going to convert to atoms, we could go from grams directly to atoms, but we're going to moles because that's what the problem asks us to do. So we'll put moles of zinc. And by definition, we know that 65.39 grams of zinc equals 1 mole of zinc. Now, all we have to do is solve the problem. We know that, now, when we're looking at these brackets, the first thing you're going to always do is you're going to just multiply everything on the top, and then you'll divide by whatever's on the bottom. So what we have is 116 times 1, which is 116. So you can put out here if we wanted to, 116, and over 65.39. But we're not really done doing anything until we look at units. So we have grams of zinc times moles of zinc, and then we have grams of zinc. What we see here is that these two things cancel. And that's the reason why when we have something on the top and something on the bottom, they cancel. So now our only unit that we have left is moles of zinc. So if you take this and you have 116 and you divide it by 65.39, you are going to get I'm having an issue here. 116 divided by 65.39, hitting the wrong button, you're going to get 1.77 moles of zinc. And that's moles. Okay, and that's as simple as that goes. So the main idea here is understanding that when you're using your periodic table to find your conversion factor. If you're going from mass to moles, you're going to use the molar mass found on your periodic table. If you're going from moles to mass, you're still going to use your periodic table and look at the molar mass of the element that you're trying to find. Now this next problem is a little bit different. It involves a little more content. So it says how many moles of sodium bicarbonate are in 25 grams of sodium bicarbonate. Well, let's go to our periodic table. And guess what? We don't have sodium bicarbonate on here. So that means what we have is a compound. And so we have to write the formula for sodium bicarbonate before we can solve this problem. So we know that we have sodium. Sodium is Na. And I may have to change this pen because I do not like that. Okay, we have Na. And it has a 1+ charge. If we look at here, sodium, and if we mark our periodic table right, all of group 1 has a 1+ charge. All of group 2 has a 2+ charge. All of group 3A has a 3+ charge. And then this is going to have a -3, -2, -1. And I'm just going to write that there for future reference. And you might write it on your own periodic table. The next thing we need to look at is bicarbonate. So we go to our common polyatomic ion list and we're going to find bicarbonate. But wait, I don't see it. All right, so here it is. It is hydrogen carbonate. It's another name for hydrogen carbonate is bicarbonate, and we can see that down here in the key. Bisulfate and bicarbonate are widely used common names for hydrogen sulfate and hydrogen carbonate, respectively. So this means this is just telling us that hydrogen carbonate is also bicarbonate. And the formula is HCO3, and look at the charge, very important. It's 1-. So just as a minus, that means it's 1-. So we come back here, and we see we have sodium with a 1+, and we also have HCO3 1-. Now that tells us that when we put these together, we have a 1+ charge and a 1- charge, and if we add these two charges together, we get 0. And because the sum of the charges equals 0, we can just, our formula is going to be NaHCO3. Now, if our charges were different, then it did not equal 0, we could not just write this. But we do know that the formula is NaHCO3 based on the charges, the sum of the charges equaling 0. So now with that, we can get our molar mass. But we can't get our molar mass now by looking at the periodic table for NaHCO3. We have to look at the molar mass for sodium, hydrogen, carbon, and oxygen and add them all up to get the molar mass for sodium bicarbonate. So if we list this out, we have sodium, and we have 1. There's only 1 in the formula, times, and we look up the molar mass of sodium, and it's somewhere around 23, 22.99. And so I'm going to say it's 23 grams. And so that equals 23. And then we have hydrogen. And if you look at your periodic table, we have, well, even first look at the formula, there's 1 hydrogen, so 1. Look at your periodic table, it is roughly 1 gram, so I'm going to put 1 gram. And then we have carbon. We have 1 carbon in the formula, and carbon has a molar mass of something really close to 12. So we're going to say it's 12. And then you have oxygen, and you have 3 times, and the molar mass of oxygen is 16 or 15.99, whatever they want to say, but it says 16 on here because it's close enough to the right answer. And so you write down 16, and then 16 times 3 is going to be about 48 grams. And so now we add all that up. And so we do so, we get something like 23, 84 grams. And hopefully that's what you got, because I don't have anyone to check me. I'm just doing this kind of fast. So yeah, that's 16, 61. Yep, 84 grams. That's very good. So now we have 84 grams per mole. That means there's 84 grams for every 1 mole, or 84 grams of sodium bicarbonate equals 1 mole, which is equal to 6.02 times 10 to the 23rd. And because this is an ionic compound, and I'm bringing this up because in another problem here in a little bit, they're going to ask us about formula units. So this is an ionic compound, meaning we use the charges, uses a metal with a non-metal. So we call this a formula unit. So instead of saying we have 6.02 times 10 to the 23rd atoms, well, we have way more atoms in that if we used all the atoms for sodium, hydrogen, carbon, and oxygen. But collectively, for this whole thing, we have 6.02 times 10 to the 23rd formula units. All right, so that's very important to know. So we have, if we have 1 mole of this compound, we have 6.02 times 10 to the 23rd formula units of this compound, or we have 84 grams. They're all equal. So if we go back and we do our bracket again, and I'm going to have a little less space to work with, maybe I'll go down on the page a little bit. Let's see. We started with 25 grams is what was given, and I told you that's what we're going to do, 25 grams. We always start with what is given, and it is sodium bicarbonate. Always write that in there, NaHCO3. And because, and my lines are a little less straight now, because we have grams of sodium bicarbonate at the top, we want to divide by that so it cancels. So we're going to have grams of sodium bicarbonate on the bottom. And we're converting this to moles. So we're going to have moles of sodium bicarbonate on the top. So now, how many grams were in a mole? Well, we did the molar mass. We found that 84 grams was equal to 1 mole. Now we simply multiply everything on the top. So it's going to be 25 times 1, which is 25. And we're going to divide by everything on the bottom, which is 84. So essentially it's going to be 25 divided by 84. So we can do that, and we will get 0.297, 0.297. But what is our unit? What were we trying to find? Well, we were trying to find moles. We have to make sure that when we're doing these brackets that we have the unit that we desire at the end. So if we gram divided by grams of sodium bicarbonate divided by a gram of sodium bicarbonate is equal to 1, so they cancel. And we're left with moles of sodium bicarbonate. And guess what? That's what we were trying to find, NaHCO3. And there you go. Let's move on to the next problem. I don't think I'm going to get through 10 problems on this one video. I think I will stop at this one because the video is getting rather lengthy. So how many moles of oxygen atoms are in 245 grams of chromium-3 sulfate? How many moles of oxygen atoms are in 245 grams of chromium-3 sulfate? Once again, we have a compound Now this compound is a little bit different because you see it has this 3 in there. What this is telling us is that chromium has a charge of positive 3. There are, unlike all of these elements in group 1, 2, and 3, which we know the charges to be 1, 2, and 3, we don't know that for chromium. And so chromium lies right here in the transition metals, and it has more than one type of charge. And I don't have that listed in a table, and quite frankly, on this problem, we don't need to have it listed on a table. We just need to know that this means that chromium has a +3 charge. So what we have is chromium, Cr, and we can give it a 3+ charge. Now we need to know, what is sulfate? Don't come over to your periodic table and see S and think that is sulfate. That is sulfur, or you could call it sulfide as an ion, but it is not sulfate. We have to look to the polyatomic ion sheet, and we look at sulfate, and we see that it is SO4, and it has a charge of 2-. That is very important that we know all of that. So it is SO4, and it is 2-. Now let's add up the sum of our charges. 3 plus 2- equals 1+. Uh-oh. That does not equal 0. So we cannot say the formula is CrSO4. So we have to do something to make sure that the sum of the charges are equal. So that's what we're going to do now. Whoops. So the easiest way to do this, and first thing you're going to want to do is just kind of make sure you understand that that's one entity right there, is just not take your charge, but take the number, the magnitude of the charge, and you're going to take the one side and you're going to place it down here, and you're going to take the other side and take it down here. No, I'm not saying -2, and I'm not saying +3. I'm just now saying that I have 2 chromiums, so it's Cr2, and I have 3 sulfates, and I have to put this sulfate in parentheses, because if I don't, this 3 will not apply to the sulfur and the oxygen. So you also have to know how to count these. So this means that you have 12 oxygen, 3 sulfur here, still 2 chromium. But why did we do this? We have to make sure the charges equal 0. So if chromium still has a +3 charge, see if I can get that in there, and sulfate still has a -2 charge, all right, 2 times 3 is +6, and 3 times -2 is -6. So now the sum of my charges equals 0. So I have to have this ratio. I have to have 2 chromium to 3 sulfate in order for this to be true. So my formula is Cr2SO4 3. Now we can get the molar mass of this compound, doing like we did on the last problem. So let's see if we can save some room here. We have chromium, and we have 2, and we have sulfate. We do have sulfate, but we have to break it down into its individual atoms, and one of them is sulfur, and we have 3 times 1 sulfur, so we have 3 sulfur, and we have oxygen, and we have 3 times 4 oxygen, which is 12 oxygen. And now we're going to multiply those times their molar mass. So we go to our periodic table, find chromium, and we see that it is 52. And 2 times 52 is equal to 104 grams. And then we have sulfur, which has a molar mass of 32. That's going to be 96 grams. And then oxygen has a molar mass of 16. And that will be 192 grams. Now what are we going to do with this information? If you said add them up, you are absolutely correct. So we're going to add all those up. Plus, and you get something like 392 grams of Cr2SO4. Make sure you put that parentheses in there. And that's what it is. 392 grams of that equals 1 mole of Cr2SO4. 3, and sorry for my sloppy handwriting. So what that means is if we have 1 mole of chromium sulfate, chromium 3 sulfate, that means it's going to be 392 grams. And it's also going to be 6.02 times 10 to the 23rd, you guessed it, formula units of chromium sulfate, because this is an ionic compound. Okay, so with that, we can start our bracket. We know we're going to start with what is given. It was given 245 grams of chromium 3 sulfate, and we know that is Cr2SO4 3, and I'm never going to be able to write real well on this thing, so you're going to just have to forgive my sloppy handwriting. And we have grams, so what should we have on the bottom here? That's right, grams of Cr2SO4. What am I missing? That parentheses, very, very important. And equal to 1 mole of Cr2SO4 3. Now, plug it in. 392 grams is equal to 1 mole. Now, 245 times 1 is 245 divided by 392. So we have basically 245 divided by 392. And we're going to make sure these cancel. Grams of chromium sulfate divided by grams of chromium sulfate is equal to 1, so it doesn't change anything. And so we're left with moles of Cr2SO4 3. So 245 divided by 392, and you should get 0.625. Just want to make a real quick point here, is that this expression right here, these values right here are equal. This is the same thing as saying, we could say that 1 dozen and 12, they're equal values. So if I take 12 and divide them into a dozen, I get 1. If I take 392 grams into 1 mole, I would actually get 1. So I'm not changing this value, I'm just changing the unit associated with that value. So it's very, very interesting. Anyway, I'm going to stop right there and upload other videos, but it seems like I have taken my sweet time just to get through these 3 problems. So I hope this helps, and I will make sure to continue on. Thank you.